So the last part of section 9.4 that we have to cover is rationalizing the denominator when you have a binomial like this in the denominator. Now by rationalizing the denominator, really what I'm saying is I want to get rid of all the square roots. I mean, no one likes square roots, so let's see if we can't get rid of them. In these problems, there's a little bit of a trick to getting rid of them. And the trick is we're going to multiply by 1. That's really all you can do, is multiply by 1. Because if we multiply by anything else, or did anything else, you'd be changing the value of the expression. Multiplying by 1 doesn't change anything. If your boss says, hey, I'm going to take your salary and multiply it by 1, you're not suddenly going to add them to your Christmas card list, right? Multiplying by 1 doesn't change anything. But a clever form of 1 can help out. So here's that clever form of 1. We're going to multiply by something called the conjugate. And we've done this before today. In fact, it was just a few problems ago, where you have an expression like this. You multiply a similar expression, except change the sign. 4 plus the square root of 6 and 4 minus the square root of 6. So that's the trick here. And I'll do that in the numerator and the denominator. So if I do it in the numerator and denominator, effectively I'm multiplying by what? By 1, right? Because this and this would cancel, except you don't want to do the cancellation. You want to multiply it all out. So how does that work? Well, here in the numerator, I'll distribute. I'll get 5 times, or square root of 5 times 4, or 4 times the square root of 5. Right? Remember, the 4 is outside, the 5 is inside, so they're not going to multiply against each other. Minus what? Minus the square root of 30. 5 times 6, 30, that's under the radical, so we're good there. In the denominator, we're going to FOIL this out. So it's going to be 4 times 4 is 16 minus what? 4 square root of 6, making me look good, Michelle, thank you. Minus 4 square roots of 6, then the next term, the middle term, plus 4 square root of 6. More people making me look good, great. Plus times a minus is a minus square root of what? 36. Now something special happens here, right? What special thing happens in the denominator? Those cancel. Yay. Wow, that's pretty cool. Happy faces in the back row. Good deal. So in the numerator, I'm left with 4 square roots of 5 minus square root of 30 over 16 minus 6. So your final answer for this one is 4 square roots of 5 minus the square root of 30 over 10. And that's it. Please don't be tempted to cancel the 2 from this into the 10 here. This is one whole term. You can't cancel into that. So that's as far as we can go with this one. Yay. That wasn't so bad. The thing you want to keep in mind is this trick here. You're going to multiply by the conjugate of the denominator, both in the numerator and denominator. So if this was a 4 minus 6, I would have multiplied by a 4 plus 6. 4 plus 6, you multiply by 4 minus root 6. So you just change the sign there in order to get that conjugate. Anything on this one before I move to another one? Okay, let's try another one then. Let's try the one right below that one. Square root of 13 over the square root of z plus the square root of 15. So again, you're going to rationalize the denominator. So we're going to multiply by 1, but what's the form of 1 that I'm going to choose for this particular problem? Thank you. A couple of you in stereo. Well done. So let's do this. I'm going to put parentheses in both the numerators and denominator. So square root of z minus the square root of 15, square root of z minus the square root of 15. So more practice with multiplying out these binomials. That's probably a good thing. Where do you want to start, the numerator or denominator? Numerator? Okay. So square root of 13 times square root of z, well, nothing much there. Square root of 13z. And 13 times, that's what, 195? Yes. Someone check me on that? Thank you. Square root of 195. Now in the denominator, square root of z times square root of z. Square root of z squared minus, what's the outside terms? Thank you. Square root of 15z. Inside terms, you have a plus times a plus. So plus the square root of 15z minus the square root of, I'll help you out here, 225. Or you could just write 15 squared. Works out either way. Brandon, there's something nice that happens here, right? In the denominator, some nice simplification. Perfect. Thank you. They cancel out. There's some more simplification that we get in the denominator. What else can you see that happens in the denominator? Square root of z, square root of z. Good. Minus 15. And that's it. We're done with this one. Yay. All right. One last one like this. A little bit more challenging. But are we okay with the general ideas here so far? The idea is to multiply by 1. I mean, this right here is 1. It's something divided by itself. When you have an expression you're trying to simplify, that's kind of like one of your best tricks. Multiply by 1. This is not an equation. I don't have this equals something and I can do something to both sides. You're just going to start out with this. Just an expression. So you can't multiply both sides to clear out a denominator. You can't square both sides because there's no both sides. You just have an expression, and your only trick is to multiply by 1. We did that there. All right. Let's go down a little bit. Let's try this one. So the top one of those two. 8 minus the square root of x over 8 plus the square root of x. So that's our expression. We're going to simplify this. Again, the trick is to multiply by 1. Now, when you're determining what to multiply by, you should be looking at the denominator. You're going to multiply by something over something. Eight minus the square root of x. So again, the key thing here is to change this sign. So 8 minus the square root of x and 8 minus the square root of x. Yeah, I get it. They're both the same in the numerator. Okay, that's fine. Let's FOIL it all out. In the denominator, you should get some nice simplification. In the numerator, you get some simplification, but it's not going to completely go away like it will in the denominator, or nearly completely go away in the denominator. So I'll give you a chance to work on that. I'll walk around, try and help out. If you have some questions, try and flag me down. Okay, so in the numerator, 8 times 8 is 64. Minus 8 square roots of x. Minus 8 square roots of x again. Minus the square root of x squared. In the denominator, I'm going to get something very similar, right? The only difference is that the middle term is going to be a plus 8 square roots of x. And the nice thing about that is that it means these terms cancel. They drop out. Where? There we go. So there was some dust. I think it prevented you from seeing that there was actually a plus there. Thank you. All right. So let's finish this one up then. 64 minus x. And in the numerator, 64 minus 16 square roots of x plus x. This is as far as you can go. That term is one whole term. You can't cancel into that. This is one whole term. I can't cancel parts of this. I can't cancel the 64s. I can't cancel the x's. That's it. So just leave it there. We will see some stuff later on where you can do some more simplification. In fact, let me give you kind of one example. If I had 4 plus 8 square roots of 7 divided by, let's say, 6. Here I can actually do something if I wanted to. Now, like before, as I promised, you can't cancel into something like that because it's an addition. These terms are stuck together. They're married. If you break up that marriage, you're going to write homewrecker all over your test, right? Don't do that. They're married happily, yes. So you can't break up the marriage, but what you can do is you can send the kids out to college, right? So how would you do that? You'd factor out the 4. That leave behind 4 times 1 plus 2 square roots of 7 over the 6. And now what's the difference? Now, yeah, 4 and the 6, you can cancel something here. The difference is you're not breaking up a marriage. You're not canceling into this parentheses, right? You're not canceling into that expression. And everything here is multiplied. So I can do this. I can say, all right, 2 goes into 4 twice, 2 goes into 6 3 times, and this is what I'm left with. I'm left with 2 times 1 plus 2 square roots of 7 over 3. So that's the difference. For those of you who want to cancel, that's how we're going to do it. We will see stuff like this eventually when we work with the quadratic formula. So that's where we'll get this. I haven't seen it in the homework that you're going to get in this section. I don't think you will get it. But for those of you who are dying to do that cancellation, that's how you really have to do it. Okay, with the last two here, particularly this one. Do you get the general flow of these things? You just multiply by the conjugate. So you just take whatever this is and change its sign, and that's what you're going to run with. Cool. Thank you so much. So that's a little bonus for section 9.4.